Welcome, my dear friends. Today we'll discuss on the topic trigonometry. Here we'll try to see how we can approach a equation of trigonometric identity, trigonometric ratios, equations of trigonometric ratios, how to solve. Okay, before we start to solve those trigonometric identities, we need to know two things mainly. One, that is the tool that will be used, mathematical tool that will be used to solve the trigonometric identity, and some steps, or you can say key approach, how you can approach such type of trigonometric equations. Okay. Mathematical tools. So these are the tools you need to know, and these tools you have to by heart. So I hope you mathematical tools. You can see here reciprocal ratios. So these are the reciprocal ratios you need to know. The reciprocal of sine is cosec, and inversely reciprocal of cosec is sine. Similarly, reciprocal of cos is sec, and conversely reciprocal of sec is cos. Similarly, tan, reciprocal of tan is cot, and reciprocal of cot is tan. So this is one tool. Next tool, you need to know trigonometric identities. Like already we have discussed this in our one of the videos. So sine square theta plus cos square theta is 1. From here we can derive again some identities. Sine square theta is equal to 1 minus cos square theta. So these are the derivatives from this identity. Again another identity, sec square theta plus 1 plus tan square theta is equal to. So this is one identity, and these are the derivatives of that is derived from these identities. This is another identity, and this is cot square theta. Okay, cot square theta, not cos. So these are the derivatives from this identity, and other two identities, tan theta is equal to sine theta by cos theta, and since they tan and cot are reciprocal, so cot is equal to reciprocal of this quotient, that is cos theta by sine theta. Another third tool that we need is algebraic identities, like a plus b whole square is equal to a square plus twice ab plus b square, a minus b whole square is equal to a square minus twice ab plus b square, a square minus b square is equal to a minus b, a plus b. So these are the few tools you need to know before we start solving equations of trigonometric ratios. Next, key approach. Okay, so these key approaches are based on my experience and my knowledge. So this key approach may differ from individuals. Okay, so first point I have note in my key approach is identify the complex side and start simplifying that side. Okay, now what does this complex side I mean? That is having more operations, means plus minus, and more terms and more ratios. Like you can see we have the trigonometric equations of trigonometric ratios. Okay, so if you compare these two sides, this side is more complex because here we have more ratios, more operations, and more terms. So this is called complex side. We will solve this complex side first. Okay, we'll solve this complex side first in this way. So how? So these equations, these trigonometric equations I have taken. Okay, so this is the equation. So I will take LHS. Cos A by 1 plus sine A plus 1 plus sine A by cos A. So since they are in fraction, I will take LCM. So LCM of this denominator and this denominator will be the product of these two denominator. So this is the LCM, product of these two. Now as we know, you have to in such type of fraction, so after getting the LCM you just cross multiply to get the numerator. So this will be cross multiplied with this, so cos A into cos A will be cos square A. Okay, you cannot write, you cannot write cos A square. Okay, so this is the wrong approach. Again, this two if you multiply it will become 1 plus sine square 1 plus sine A whole square. Now here I can use identity, that is algebraic identity, a plus b whole square, a square plus twice ab plus b square. So a square plus twice ab plus b square. I have used algebraic identity. Okay, next, again in this step, since I can use identity, trigonometric identity, so I have applied. So cos square, you see the first trigonometric identity, sine square theta plus cos square theta, angle same, then squares of sine and cos is equal to 1. So square of these two trigonometric ratios will be 1, then 1 plus twice sine A, so it will become 2 plus twice sine A. So now you can take, so this will become 2 plus 2 sine A. Now you can see, whenever you see anything you can take common, first take that common out. So 2 is common. Okay, so 2 1 plus sine A, then cos A, 1 plus sine A, 1 plus sine, this to be cancelled each other because both numerator and denominator having same factor, 1 plus sine A, 1 plus cancel, then we have 2 cos A, okay, is equal to 2 sec A. Why sec A? Because sec A is equal to 1 by cos A. They are reciprocal of each other. So this is the first approach. What we have seen in the first approach, identify the complex number and try to simplify. Okay, now second one, in some case in the complex side, even though you choose complex side, we will be not able to simplify. Okay, so it will be very difficult us to simplify if we have no proper identity. Okay, for example, but in some case you will have both sides are complex. See here in this example, both sides are complex. You cannot say that this is less complex and this is more complex. Any one is complex. So in such case you can start from any one of the side which you feel easy. Okay, now see here we have no direct identity to apply here. So in such case we will change the other ratios to sine and cos. For example, cosec will be changing to sine and cos, which is suitable. Similarly, cot also will be changing to sine and cos. Okay, how we'll solve this, let us see here. Okay, let us take this. What I said, I will change to sine and cos. Now cosec can be changed to sine because cosec is a reciprocal of sine. So 1 by sine theta, and cot is equal to cosec by sine theta. You can see the trigonometric identity here. Cot is equal to cos by sine. So cos by sine, we have whole square. Now take LCM, both denominator sine, so sine will be LCM. Okay, so since the denominator same, so numerator will be the since minus or difference of these two numerator. Okay, I think till this point okay. Now whole square, I have distributed both in numerator and denominator. Sine whole square is written as sine square theta. And now here we will be using identity. Okay, here we will be using identity, sine square theta identity. See, here you can derive sine square theta is equal to what? 1 minus cos square theta. So this identity will be applied here. So I have applied here trigonometric identity. Sine square theta is equal to 1 minus cos square theta. So 1 minus cos square theta. Now this expression again can be expressed in a square minus b square. This is a square and b square. That means a minus b, a plus b. So a minus b, a plus b. Now this you can write in a minus cos theta into a minus cos theta, and from here you have same factors both the numerator and denominator, that is 1 minus cos theta cancelled. Then we have 1 minus cos theta by 1 plus cos theta, which is our other side. We have start from LHS and we come to RHS. So in this approach, what we'll do, if we are not able to simplify or we are not getting idea, so normally we will change to sine and cos. Okay, clear? So which I feel very easy to solve when I have sine and cos. Okay, clear? Next, you can just categorize. Another approach is called rationalize. Okay, in some case, if you see that rationalizing can be denominator or it can be numerator. Okay, so if you see rationalize the numerator, anyone you rationalize, then it will be easy. We can see the same rationalize pattern in the same example. How? Let's see. So when you say rationalize, let's say I have 1 minus cos theta and here I have 1 plus cos theta. Rational means just change the sign and multiply, having the same terms, just operation is changed. Plus will be minus, minus will be plus. If I'm going to rationalize here, so I will be multiplying here 1 plus cos theta both in numerator and denominator. Here in this case I have rationalized the down part, so 1 minus cos theta, because here plus, here minus. So this is the rationalized technique. Okay, normally it is not called rationalize, but it is the rationalized technique. Okay, see how. Same example, this time we have started from RHS. So if you see here in the RHS we have this, we have to prove this LHS. Okay, so RHS. So now we are going to use the rationalized technique. Okay, here in the denominator, so plus, so we will put here minus. So this 1 minus cos theta will multiply both in numerator and denominator. Now here we have 1 minus cos theta, 1 minus cos theta. That means 1 minus cos theta whole square. And this becomes a plus b, a minus b. That means a square minus b square. A means 1, so 1 square, and cos square means cos theta whole square means cos theta, cos square theta, sorry, cos square theta. Again, if you take the help of identity, 1 minus cos square theta is equal to sine square theta. So here we have used the identity sine square theta. Now both have square, so take whole square, 1 minus cos theta by sine theta whole square. Then this you distribute in this 1 minus sine theta minus cos theta by sine theta. Then 1 by sine theta is equal to cosec theta, and cos theta by sine theta is equal to cot theta whole square, which is equal to LHS. So in this way, sometime if you see that rationalizing technique help us to simplify the equation, we'll take the help of the rationalize technique. Okay, next approach. If after applying all the above mentioned approaches or techniques, still we are not able to simplify further. Okay, say we have applied all the three, that is sine, we have changed to sine cos, and we have rationalized whatever is applicable, we have applied, still we are not able to simplify. Then what will stop? Okay, that means this is already the simplest form of that expression. Okay, what does this mean? If you're not able to further simplify, this is already the simplest form of that statement. Okay, so we'll stop there and we'll start from RHS. If you're starting from LHS, we'll start from RHS and we'll make sure both LHS and RHS are same. So this is the another approach. Normally when above three approach fails. Okay, let's see. Let us take this example. So we want to prove this two trigonometric ratios same. Okay, so what we'll do, let us take, okay, so let us start LHS. So 1 plus sec theta by sec theta, as we said, let us change to sine and cos because we do not have any idea what to do. So sec is a reciprocal of cos, so 1 by cos theta, so you take LCM, so here down, so cos theta is the LCM, so cos theta plus 1. Okay, I think this is clear. Now this like this, 1 plus 2 by 3 is equal to what? 3 plus 2 by 3. Okay, same like. Now numerator we have fraction, so write this. Denominator also we have fraction, so write the denominator, multiply and reciprocal. So sines and cos, we have cos theta, cos a plus 1. Now this is the simplest form of this, which further we can, but for most of us will be problem. So what we'll do, we'll stop here, we'll take RHS. In the RHS, if you see the expression, just rewind the video and see, you will get this is the RHS part. So now we take RHS. So sine square a, already you know sine square a means what? 1 minus cos theta, that means cos square a. So 1 minus cos square a, this is again a minus a square minus b square, so a minus b, a plus b. Now you see you have same factors, 1 minus cos a in numerator as well as denominator cancelled, then we have 1 plus cos a. Now if you see both LHS and RHS, we have cos a plus 1 plus cos a, it is equal to cos a plus 1. We have LHS equal to RHS. That means what? That these two trigonometric ratios are same. Expression of these two trigonometric ratios are same. So this different approach we can apply. Hope this video gives you clear idea how you can start. Okay, and before ending this tip, okay, few things. Try to use identity. If not possible, change into sine and cos. Okay, again, whenever you have common, take the common out. Clear? Thank you.